Hello everyone. I will continue our discussion on artificial neural network. So we started with the very basics of artificial neural network, how it is similar with human brain architecture. Then we discussed different layers or different components of ANN architecture, and also we have some idea how really one ANN works. Now we'll have few more basics on ANN. First thing is that there are majorly two kinds of neural network. Exactly how they work, based on that, we may say that the ANN may be a feed forward network or a feedback network. Now, what is a feed forward network? It is like containing input, output, and hidden layers, and signals can only travel in one direction. Means the signal may travel from input layer to hidden layer to output layer, but not the vice versa. That's why it is known as feed forward network. Processing element computes based on the weighted sum of its inputs. So at every step, you know that as we discussed earlier, whatever the inputs are coming to the input layer, then there are some weight parameters are there which are being multiplied with the inputs, and then it is being processed in the hidden layers. It can be it can be one, or it can be many hidden layers, and after that the finally the output comes to the output layer, and after using any activation function, finally the output is generated. So that is the way this kind of neural network is working, where the signal is passing from input to hidden layer and hidden layer to output layer, not in the opposite direction. So the main use of this type of network is in data mining, because data mining is something where we have lot of data, and the data we are processing and trying to get the inner meanings of it gradually. Means we are just going in the details of the data. So that's why feed forward network is a uh, suitable for this data mining type of applications. So just for our knowledge, we'll again draw, say these are my input layers, then say I just draw with different colors some hidden layers maybe. Okay, say I draw two hidden layers. These are my hidden layers. Okay, and this is my output layer. So output is generated from here. So if the inputs are x1, x2, x3, these are the inputs coming to the input layer. I am feeding the input features to the input layer. From the input layer, the data is passed to the hidden layer, and from one input layer it may go to multiple hidden layers as well, and then after processing in the hidden layer, it may go to the second hidden layer. Okay, and after processing, so it can be many combinations. Okay, from any layer to any layer it's possible. At any level to another level, the information may be sent in many different ways, and it can be the combination of information at a particular layer, and then from the hidden layers the output is coming to the output layer, and finally from the output layer my required output is getting generated. So here the information is passing from the left to right only. Okay, from input layer to hidden layer 1, hidden layer 1 to hidden layer 2, and hidden layer 2 to output layer, and from output layer the output is generated. So this is a scenario where it is working as a feed forward network. Next is feedback network. We have already discussed that there is a concept of back propagation, where the information or the data that is being sent from a layer at the left to the right, then after calculating the cost function, that information may be sent back. So this type of network has application in optimization problems. So there are some scenarios, some problems where you have to find the best solution. So whenever you have to find a best solution, then what you do, generally we do the process whatever way we are trying to find the solution, we try to do it in all possible ways, or we learn from the previous steps and we try to improve it continuously. So that is the kind of optimization problem where your feedback network is very much applicable. Okay, so here we have signals traveling in both direction using loops. All possible connections between neurons are allowed, means here it's not like that only from left to right, but it is possible that the signal is being sent back, means from hidden layer 2 to hidden layer 1, or from output layer to hidden layer 2. So this type of communication is possible in feedback network. Nonlinear dynamic system which changes continuously until it reaches a state of equilibrium. So it's like a continuous process where you are trying all possible combinations of values, adjusting the weights, adjusting the bias, everything you are adjusting so that you are getting the best possible solution. So for this type of problem, you should have the feedback network. So in feedback network, how the signal is being uh, traversed, it's not only from left to right but from right to left as well, something like that. Say first of all the signal was sent from hidden layer 2 to output layer, but again I may send something from output layer to hidden layer 2, and sometimes from hidden layer 2 to hidden layer 1. So all these types of possible forward and backward communication, both are possible here in feedback network. So these are the broadly two types of neural networks. Now the advantages and disadvantages. Okay, so we got some idea that what is artificial neural network and how it works, what are the different components of ANN, not in a very detailed manner, but we have some idea. But we should also understand that what are the really the features about ANN. Sometimes it may seem to us that okay, it is good, it is advantageous, and sometimes it can be disadvantageous when it is not possible to fulfill that feature or characteristics. So basically they are the key features or characteristics, but at the same time they can be advantageous, this can be disadvantageous. The first thing is that it performs well with linear and non-linear data. That is very important, that here all possible type of data may be sent and I can process it in many different ways. Okay, because here you can understand that we can send the data in all possible combinations from one layer to another. We have the option of sending back the data. I can just connect any neuron with any other neuron. So for all these possible uh, possibilities that we have, for that we can say that it is not limited to any particular type of data, any type of data, any type of relationship we can maintain, we can build with this ANN. Work even if one or few units fail to respond to the network. So it is actually a complex network of nodes or neurons where there are a numerous number of neurons who are working to generate the outcome. Here if one or few units fail, means may say one layer, part of one layer or some of the neurons are not working, still the network can work. So it is not having 100% dependence on the nodes. It's like as it is huge, so if most part of it is working, then also we can continue our work. So of course these two are the advantages only, right? Now much processing and storage resources need to be committed. So as you know that it requires a huge computation power processing unit. That means you need a strong system actually to build this ANN from your training data to to build this network and to train it, you need a lot of resources, means you need processing power, you need storage, and you need time as well. So those are the things that you have to supply. Otherwise you should not go for ANN if you cannot give this much resources. Otherwise what will happen, that that network cannot be completely trained to really be helpful for you to test on the data that you are supplying. So that's why processing power, storage resource, those things are very crucial for really working of the ANN. Learns from the analyzed data and does not require reprogramming. Of course, that it actually learns most of the things from the data that you are supplying. That's why it is very much required that to have the optimum performance from the ANN, you have to supply a large diversity of training data, lot of data, and the all possible values in the training data. Means it should be a very good training data set that you should supply. Then only the network can learn properly, and then only it can work properly. That is very important. And it is known as black box model. What does that mean? That you cannot really understand that actually how the network is working. Okay, you may have the knowledge about the structure of the network, but actually how this logic is evolved, how this outcome generation process is working, that we can't have the detailed knowledge. That's why it is known as a black box model. So if you are looking for something where you really want to know each and every part of the program, that how my data is getting processed, on based on what logic the outcome is getting generated, then this model is not suitable, because this model will not give you much insight about the really how it is working. Okay, so I can just say that from advantage point of view, we can say that it can process linear and non-linear data. If some part of it is not working, still it can continue its work and generate the outcome. Okay, and it learns from the analyzed data, and you don't need to do lot of programming here. It's actually not required. But at the same time, we have some disadvantages, that first of all, it needs a lot of data, different different types of data. Means the training data should be very good, very sufficient for doing the processing. And then you need the computation power, you need the storage, you need the time to train. So these things if you can supply, then ANN can do magic for you. So that is about the introduction to artificial neural network. Now we have the brief about exactly what is artificial neural network and what is the use of it and how it works. Okay, now there are a lot of things about artificial neural network that we'll discuss gradually. But before completing this session, I just wanted to talk about the different architectures. So when we are talking about neural network, it's a generic term, but neural network can have different types of architecture. Means exactly how it is working, how it is performing, how the nodes are structured. So based on that, we have different architectures, they have some different names. So starting with recurrent neural network or RNN, then we have convolutional neural network, then we have reinforcement learning, we have generative adversarial networks, and deep learning. So these are some of the representations of artificial neural network. We'll have some separate discussion about each of them. So we are completing it here. We'll close it and we'll continue with the different topic on artificial neural network in the next session. Thank you.